This is Lucas. He works in a public library. He and his colleagues are involved in a community science project that includes researching, preserving, and digitizing documents about a local historical event. In the course of the project team will gather and create a lot of data. They will write budgets, reports, and other project documentation. They will take notes from historical sources and interview people to find out more about the subject of their research. They will digitize historical documents, and they will publish on the project's social media platforms. All these activities involve various types of data. The data will need appropriate storage space, access control, and management. So at the very beginning of the project, the team needs to plan what data to discard and what to keep, where to store data to make it accessible, and how to organize it to make it findable, what to share and what to protect, and what should be preserved for long-term availability. These decisions will make their work more efficient, help them understand what happens to their data, and also help them assess the project's impact once the work is done. It's all part of a process called data curation. In this session, we will look into the basics of data curation, in particular the requirements for data storage, preservation, and organization. We will also learn how to apply these basics in an institutional project. This should help you create data management plans for your projects and contribute to your institutional data practices. So, what is data curation? It's the process of organizing and maintaining data so it can be accessed and reused. It includes storing data in a safe and stable place, cleaning and organizing data, deciding who has access to data, protecting data, and preserving it for the long term. First, let's say a few words about data storage. Lucas keeps most of the project data on the hard disk of his computer at work or on the library's server. This is great for local backup, but it also has disadvantages. If the computer or server are attacked by malware or the operating system crashes, all data is compromised or lost. Besides, in a collaborative project, it is sometimes convenient for everybody to have a real-time access to the latest file versions so they can work together on them. That's why Lucas keeps some of the files in the cloud. Cloud storage means data is stored off-site on remote servers, sometimes in multiple locations. The servers are maintained by a third-party provider who is responsible for hosting, managing, and securing data. Many operating system providers, such as Microsoft or Apple, offer extra free cloud space ranging from 2 to 15 GB, and more space is offered at monthly price. Other widely used cloud services are Google Drive and Dropbox. Amazon is known as one of the world's biggest online retailers, but their most successful business are cloud computing services they provide for various customers, including NASA, Netflix, and Apple. Cloud storage supports collaboration, and data can be accessed anytime from any place or device. All what's needed is internet access. But if internet connection is slow or breaks, the access to data is restricted. Additionally, security and privacy can sometimes be an issue. Another thing Lucas's project team needs to plan ahead is what data will be archived once the project is over. Archiving means storing for a long period, and is not the same thing as backup. Backing up means saving copies of original files to separate storage space, such as an external hard disk, USB stick, or a cloud system, so that they are available in case the original files are corrupted or lost. Archiving means removing a file which is no longer actively used to a separate storage system for the long-term retention. Interview recordings and transcripts made for the project are a particularly valuable part of project data. If they are archived and made openly accessible, one day they might be useful to other researchers. That's why the project team decides to deposit them in a research data repository. It is a platform that provides management and preservation services for research data. It also makes data available for others to find and use. There are many trusted open repository platforms such as Zenodo, which has been developed under the European Open Air program, or B2Share, which has been developed by European Network of Research Organizations and Computing Centers. Lucas's team needs to find the one that best fits their purposes. They can find more information at these links. Data needs to be stored in some format. The format in which it should be saved is determined by how it will be used. For example, TIFF image files offer very high image quality, which is why they are used for archiving. But because of their quality, TIFF files are very large, so they are usually converted to JPEG to be used on the web. PNG files are smaller than TIFF but maintain the original quality, and they can be made transparent, which makes them suitable for graphic design, for example, the project logo. Once data is stored, it has to be organized in a way that will make it easily findable. Data organization includes structuring, naming, and indexing data files. An important part of data organization is naming. In a collaborative project, it is a good idea to establish 5 naming conventions that will facilitate identification and finding, such as including version number or date, or writing dates in year, month, day form, and avoiding special characters that might impact search quality. In addition, Lucas and his team sometimes assign tags to their files. Tags are keywords or terms assigned to a piece of information to make it more findable. Social media posts use hashtags, tags prefaced by hash symbol for this purpose. Most operating systems and cloud storage services provide tagging options for files as well. There are also online tagging tools, for example, tables. They can be used to tag files, emails, and bookmarks, to browse them by tags, and to share tags with others. So, as we have seen, the process of curating data that will be produced during the project's lifecycle requires a lot of planning. Lucas and his team feel a little confused sometimes, but there are places, such as the link below, where they can find examples of or even templates for data management plans and customize them to their needs. What's important to include in the plan is what kinds of data will be created or gathered during the project, what is the estimated size, where will it be stored? How will it be backed up? How regularly? What will be archived and where? Which file formats will be used? How will data files be identified and organized? Another important question in data curation is what data will be shared and reused? Join us at the intermediate level to find out. Thanks for watching the video.